Reese here with 3D Flight. Today, I'm going to be showing you how to build the 3D Flight Vesper. Now, if you haven't seen a flight video for this airplane, I highly recommend you take a look at the link in the description down below. This plane is a really fun flyer because it has a great top speed, yet because of all the wing surface area, it makes the plane incredibly maneuverable, leading to a fantastic roll rate for some really fun maneuvers. Lastly, since this plane is a pusher, it makes for a great FPV platform. So look forward to an FPV nose upgrade being released sometime in the future. Now that that's out of the way, let's go ahead and gather our materials and get started with the build.
In this section of the video, we're going to show you how to assemble the segments that make up the wing and create your cutouts for your hatch and your motor. So the first thing you're going to want to consider with this airplane is keeping the attitude of the plane for safety reasons. This is a flying wing, so there aren't many features that really help you keep the attitude of the plane. A really great solution to this is to print several segments of one side of the wing in a separate color. Then your brain can keep track of the direction of the wing is flying. You can also add tape or paint to a region of the plane, and this works as well. Once safety is taken care of, you can go ahead and start assembling. Start by removing any raft that may be on your part and clean up any remaining material with an X-Acto blade. Next, you can start gluing the segments together. We like to glue these parts together by holding them vertically. Apply glue to the bottom of one segment and then hold it vertically over the mating segment. By holding the parts vertical, the glue can really seep down into the joint and give you a really nice strong bond. Apply some accelerator, and if there's any excess glue, you can wipe it free with a paper towel. Now, we have little tabs designed in the segments, which make aligning the parts for the gluing process incredibly easy and effortless, but one thing you're going to have to pay attention to is not adding any angle in between the segments. A crooked wing will make a plane fly crooked, so do your best to avoid that. It's easy to avoid, you just have to pay attention. Once you have glued one segment together, it's more of the same, so go ahead and repeat that for the rest of the wing segments. Now when you get to the wing tips, do your best to align the wing perpendicular to them during the gluing process. It's not super critical, but it will make your wing look nice and square if you do. To complete the wing assembly, you're going to have to create openings for the hatch and the motor. We prefer to do this by using a spare tip on our soldering iron and use the hot tip to cut along the recessed areas that show the cut lines. This keeps the layers from separating, making your parts remain really nice and strong. You can also use an X-Acto blade to cut through these areas. You just don't get the added benefit of the melted together layers. In this section of the video, we're going to show you how to glue together your Elevons segments and attach them to the airframe using CA hinge. Begin by cutting CA hinge material into strips that are 0.2 inches by 0.6 inches. Next, you can glue your Elevons segments together and apply some accelerator. When gluing your CA hinges into your Elevons, we have found that it's best to do an alignment check prior to gluing them in. With the hinges aligned, add a small dab to the end and place it in its slot on the Elevon. Then you can set it aside and work on the opposite Elevon until the glue cures. With the hinges glued firmly into the Elevons, place a small dab of glue on the end of the hinges and seat the hinges into the slots on the wing making sure that your elevons can reach the limit of their travel. Now when gluing, too much glue can cause excess glue to build up on the hinge, which may cause interference between the wing and the control surface, so apply sparingly. Lastly, apply some accelerator to hold your elevons in place. In this section of the video, we're going to show you how to install your servos and control rods for your elevons. Start by installing your servo arms facing opposite directions and adding a servo lead extension based on which servo you have purchased. It's a good idea to use a servo tester while installing your servos. That way, you will avoid having to trim significantly later. Before installing your servos, you will have to trim the appendages that protrude from their sides. To install your servos, slide your servo leads up through the designed in paths on the wing. With your servos in the correct place, you can add control rods. Place a Z-bend at the front and rear of your control rod, making sure to keep the spacing correct between your control arm and your control horn. With your control rods in place, you can glue down your servos. You have a little bit of micro adjustment there, so go ahead and use it. Only a little bit of glue is necessary when gluing down your servos, because it makes it easier if you have to cut out a busted servo. Finish by adding control rod guides to the airframe. These keep the control rods from bowing while pushing your control surfaces. In this section of the video, we're going to show you how to glue your hatch together, install it using CA hinges, and add your nose guards to the airframe. Start by cutting CA hinge strips that are 0.2 inches by 0.6 inches. Then glue your hatch segments together using CA and applying some accelerator. With your hatch glued together, you can glue your CA hinges into the hatch slots. There shouldn't be any need for an alignment check on this one, but you can if you want. Apply glue to the other end of the hinges and install this in the slots on the airframe. Apply some accelerator to speed up the drying. Add nose guards to the front of the airframe with some glue. Be sure to place the correct nose guards on the correct side. They aren't very differentiable, but if you have them on the correct side, they will meet up nicely. In this section of the video, we're going to show you how to mount your motor, install your ESC and battery, and open up vent holes so that all those components remain cool. Start by adding glue to the front and rear of your motor mount. We like to do this because it adds a thin layer of insulation to keep your mount from melting in the case that your motor does get excessively warm. Just make sure to add an even layer because you don't want to add thrust angle. Screw your motor to your mount, and when doing this, align the motor so that the leads go through the receiving slot on the side of the motor mount and actually route through your motor mount. Then, you can open up holes in your airframe for the self-tapping screws that screw into your motor mount. You will find these on top and bottom near the rear of your airframe. You can open these up with a soldering iron or a drill. The size of the hole doesn't matter, just don't make it larger than the screw head. While we're at it, we may as well as open up vent holes at the front of the airframe. This keeps your battery, motor, and ESC nice and cool. If you're in an area that gets excessively warm, or you notice that your equipment is getting hot, you may want to open these up a little bit larger. Next, push your motor and mount into the hole near the rear of the airframe and secure it down using self-tapping screws. Now, one of our favorite methods for securing down our batteries is to use Velcro. You can find a good area for the Velcro to be glued down in the very nose of the plane. The battery has to be placed all the way in the nose in order for the plane to balance correctly. So place your Velcro there. Then you can install your battery and your ESC. Make sure that your motor turns the correct way. If it doesn't, you may need to flip a motor lead. In this section of the video, we're going to go over pre-flight considerations you should go over before your maiden flight. Start by getting your battery, ESC, and receiver all hooked up correctly. Then you want to make sure that your channels are set up correctly. Stick input of right roll should make the right elevon come up and the left elevon go down. Stick input of left roll should cause the left elevon to come up and the right elevon to go down. Stick input of pitch up should cause both elevons to come up, and stick input of pitch down should cause both elevons to move down. With the channels set up correctly, you should bring your elevons to neutral. Now, neutral for a flying wing includes a bit of reflex. Reflex is a little bit of upward tilt of the elevons, and this keeps the plane flying nice and level. Otherwise, you may have to trim significantly during your maiden flight. We found that about 5 degrees of reflex on your elevons of this airframe gives you nice stable flight. With your reflex added, check your throws. You can check the instruction manual for the upper and lower limits of the throw distance for this plane. Next, you can balance your airplane. There are CG markers on the wing. Place your finger on these markers, and the nose should balance slightly nose down. Now, if you have purchased our recommended equipment, this should balance easily with your battery in the nose of the plane and the ESC just behind that. If you have different equipment, you may have to add some weight to the nose, but it shouldn't take much. Lastly, install your prop and tighten the prop nut. Make sure your prop is spinning the correct way prior to your maiden flight. Since this is a pusher, your prop should be spinning clockwise. This creates a self-tightening action on the prop nut.
Hey, thanks for watching our video. We really appreciate the support. If you like what we're doing here, you should go ahead and subscribe to our channel. Now, if you have a 3D printer and you've been thinking about getting into the RC flying hobby, you should go ahead and do it. It's a lot of fun, and you meet a lot of great people every time you go out to the airfield. Also, if you are into RC flying and you've been thinking about getting a 3D printer, you should go and get one. It's a useful tool, and it helps you create whatever you want to make. Lastly, what I want to leave you with is please don't pass on these files. There takes a lot of time and effort to create these planes, and your support is what keeps us doing that. So if instead of passing on files, you're going to pass on the word to your friends, that'd be great. Till next time.